Well, welcome to Data Lakehouse 101. My name is Monica Miller, and I am a developer advocate here at Starburst. I am joined by my fabulous colleague, Tom Natz, Director of Customer Solutions. Please enter any questions that you have into the Q&A panel, and we will address them at the end of the webinar. Let's get started. So Data Lakehouse 101 with Starburst Galaxy. So let's start by talking about a data lakehouse. What is, a data lakehouse? What purpose does it serve? In today's day and age, data has definitely evolved from the structured, predefined data that used to be loaded into an on-prem database in nightly batches. Now there are all different types of data ranging from unstructured, semi-structured. Like for example, we have some event unstructured data that we need to now be streamed into our data lake. A data lakehouse actually converges both the principles of a data lake and a data warehouse to create the best of both worlds. Data lakehouses are built on object storage and follow the separation of storage and compute principle that has been rapidly gaining in popularity for good reason and provides flexibility to previously unthinkable what we could do before with our on-prem storage solutions. You can leverage, basically the data lakehouse lets you leverage your open table formats to apply a data warehouse-like functionality to the data lake. And it lets you capitalize on those low-cost cloud storage systems, which create the data lakehouse. Inside of that data lakehouse, we will be building a reporting structure, which kind of prevents the dreaded data swamp that many data lakes have turned into. And we'll get to that as an example later in the webinar. So it's a lot easier to identify what you're missing through constraints that you've run into within your own ecosystem. So what we've done is we've outlined some of the main reasons within your org that may indicate it is time to actually adopt a data lakehouse architecture. Sticking with our event data example that we previously discussed, if you have a need to store data, but you only have that data warehouse, that would be one of the reasons to investigate a data lakehouse. If you have new unstructured or semi-structured types of data, which need to then be addressed or stored somewhere, the data warehouse just really doesn't have that functionality. It also doesn't have the cost-effective and scalability issue or scalability things that a data lake can do. So if you are already streaming your data, like let's say into a data lake, but you don't have the performance and reliability you expect, that would be another time it might be beneficial to adopt a data lakehouse. The data lakehouse lets you leverage the data warehouse functionality of performance, reliability, ease of use, being able to just query with your ANSI SQL queries on the low-cost storage of a data lake. So what we're going to do is we're going to go through some of the components of the Starburst Data Lakehouse. We're going to talk a little bit about optionality, flexibility, open table formats, performance and scalability, and then native security. What we want to do is call out these components and really address what makes them the data lakehouse and how they contribute to a successful storage system. So let's talk about optionality. Here at Starburst, we believe that you should incorporate optionality into your data ecosystem. That way you can future-proof your architecture for any technologies or data innovations that arise. We all know that the postmodern data stack, it's kind of like a hot term, but it is growing rapidly. And who knows, there may be a new tool that you want to incorporate in a year that we don't know about yet. By embracing that separation of storage and compute with your data, you're able to do whatever you want with your data. You can prevent vendor lock-in and you can remain agnostic in your cloud storage because we can connect to multiple different clouds, your table format, and even your data sources where you're getting that original source of data. So by building your data lakehouse with Starburst, you can rest assured that you can integrate multiple different table formats and connect to different clouds to fit your needs. So the next thing we want to discuss is flexibility. The Starburst Data Lakehouse also lets you incorporate flexibility into your ecosystem. It lets you specify your cost and performance efficiency that fits your needs. Specifically, you get to specify the cluster that makes sense for you. Especially with cluster auto scaling that is now enabled, it lets you scale up and down your compute resources automatically and meet the demand of your actively running queries. Starburst Galaxy also lets you run both interactive and long-running queries, utilizing ANSI SQL for your data transformations that you want to do. We also have a new feature called schema discovery, which allows you to analyze a root object in your object storage location and return the schema structure of any of the discovered tables. This helps you get the most out of your data, which can be stored in many different file types, such as JSON, Parquet, ORC, and text. And it's just another part of the flexibility to get the most out of your data. So let's continue on and talk about on the theme of autonomy and talk about open table formats. The Starburst Data Lakehouse has enabled Starburst Galaxy to connect to multiple different open table formats such as Hive, Delta Lake, and Apache Iceberg. We know we have big Apache Iceberg fans in the crowd, and definitely it's used in a lot of our demos, as well as Delta Lake has some amazing features that we've been able to utilize. And all you have to do is pick your format of choice when you're configuring your object storage catalog, and Starburst Galaxy will manage the rest behind the scenes for you, so you don't have to. This lets you kind of leverage the power of these open table formats, the faster performance, the additional benefits like schema evolution, time travel, more of the benefits of those open table formats. But you can also work with different table formats seamlessly, again, allowing you to instantly leverage the data warehouse-like functionality within your data lake or your data lake house. Moving on to performance and scalability. With connections to multiple on-premise and cloud-based storage locations, and a highly performant query engine built at scale, Starburst Galaxy is the best engine to power your data lakehouse. Starburst Galaxy is built on Trino, which is designed to query data at a petabyte scale and high concurrency, and has multiple cost-based optimizations built into the engine to be as efficient as possible. You can easily and automatically scale up and down your clusters to accommodate the workloads and meet your demand. We touched on this beforehand with the flexibility, but it does come back to a scalability, just something that really allows you to reduce your infrastructure cost that may be required for your target experience, because you can then auto scale your cluster to only meet that peak performance at that specific time. And then let's jump to talk about native security. Your lakehouse must also incorporate some type of native security in order to ensure data governance and data compliance. We know that those are also really evolved within the last 5-10 years, is really how we manage our data and the types of rules and regulations we have around it. Starburst Galaxy has now incorporated some storage location based off of privileges so that you can specifically assign privileges to a location. That's down here, this example in the corner or in the bottom of the slide. And Starburst Galaxy also lets you assign role-based access control down to the table level. And so you can configure all of the proper access for a multitude of different users. As an administrator, you can completely customize access for multiple different roles, allowing you to assign different privileges to different groups of users. You can also configure your SSO identity provider to include Starburst Galaxy as a supported application, which is currently supported by Okta, Azure AD, and Google Workspace. So we've talked a lot about the what of what is a data lakehouse and what is the components of it. Let's now dive into the how and discuss how to build your Starburst data lakehouse. Now, within our data lakehouse reporting structure, they go by many names and they serve, there are 3 different layers. We've heard them as raw, stage, bronze. There's different names for each different of the reporting structures, but there are 3 different layers. The LAN layer, which stores the raw data and any unmodified data from your original source at any type of granularity. The structured data is then used for joining, enriching, and cleansing data. It's that middle layer. And the consume layer holds your aggregated data that is then ready to be queried. To enable your data lakehouse, let's walk through just an example of the architecture. So take the reporting structure and let's implement it into an example of today. So basically what we're going to do is you see our data sources here on the left. You can gather your external data sources, and what you want to do is land those in your LAN layer, properly named. From there, use Starburst Galaxy to then clean your data with your ANSI SQL transformations and basically apply your structure, make your structure layer within your reporting structure. And then from there, you can make your consume layer, which is ready to be queried from your all types of different users. Your data lakehouse will actually, it can incorporate, these are the different open table formats that we discussed: Apache, Delta Lake, or Apache Iceberg, Delta Lake, and Hive. And this is on the clouds that we have down here. And also within your reporting structure, Starburst has the ability to connect to different tools to actually create more of a robust data pipeline, like Great Expectations, DBT, Airflow, and Dagster. This is how you this is where you can get your ETL pipelines or your ELT pipelines from your data lakehouse, which you use to create your reporting structure. And here we also have the ability, we talked about, you can do both the batch and interactive. Here you have the ability to do your interactive queries. You can connect to your consume layers to your BI tool of choice and set up your analyst to have maybe read-only access to those consume layers or those consume tables and create dashboards or reports for your choice. So now this is an example of the demo diagram. Tom, you want to take this and maybe talk about it before you jump in?
Sure. Yeah, this is typically what we see from a lot of our customers is they're looking for a better way instead of going into I call it Oracle in the cloud. So they have data that's being landed in S3 or Azure or GCP, usually JSON or CSV or something like that, and they need to take this data and sometimes just report directly on it. Sometimes they need to go into more of a integrated layer, join it, enrich that data, add business rules to it. And so in this diagram here, we show where we're landing data in, we're creating structured tables out of that. Structured meaning there may be some, a lot of times you get data from a source system, it doesn't make a lot of sense to somebody. So adding some metadata to that data. In this example, I have just a very, very simple example where I have sales information and customer information coming in. So that's going to go from JSON into Iceberg. And the idea is, every minute, every 10 minutes, every whatever, micro batch it, every hour, that data can be landing into JSON and be able to take that data and move it over to Iceberg tables that are going to be more highly performant. And then from there is create reporting tables. And this is a typical use case that we see a lot. They just need to land data. They want multiple data sources in. They want to be able to join it together and then be able to create reporting tables for BI, aggregate tables. And then from there, that structured area in the middle, open that up to any kind of ad hoc querying or even ad hoc querying down to the reporting tables as well. So this is kind of what I'm going to build. It's based upon a blog that I have that one of these days I'll actually post. I just keep using it for webinars. So I'm going to post it one of these days, but I just use that to go through this. So
awesome. So I think let's get started with that. I'm going to stop sharing.
Okay.
And throw it over to you.
All right. Let me go ahead and share my screen. Okay. I have this little S3. Let me move the Zoom window out of the way. So can you see the little S3 Explorer over here, Monica?
Yes, I can.
Okay. So I have, I like to show the data, especially when I'm dealing with Trino. It's different from a database. People are used to a database where you don't get to see any of this stuff. This is that I fell in love with Presto at the time, which is now Trino, because it was a database without storage. You brought your own storage, and I was blown away by that because I did Oracle and Teradata and all those good databases, Informatica for many, many years. And this was different for me because that was always kept, that was the secret sauce of any database. And now this is completely blown wide open with Parquet and Org and Iceberg, that anybody, any of these engines can come start working on this data. And I have this little diagram that I have, I call it what it's Iceberg. And along with Iceberg and Trino, you have this like open architecture. And I don't mind showing a lot of these places. So this is all the different kind of companies and open source projects that have jumped on Iceberg. And the reason why it's so popular is because this bottom part is yours. You own this data, and you have all these tools coming through a common API called the Iceberg API. Everybody's reading and writing and altering data through this API. So any of these other engines can come read this data. So what we like about this and what our customers like about this is I'm not pigeonholed, or I'm not going into one specific table format that only a couple other engines support, or I'm going into some other cloud data warehouse that I have to, maybe in 2 years, 3 years, maybe I want to get out of it. It's going to be very, very expensive. So this is why we really like Iceberg around here, because it is really a true open source format, table format. Nobody owns it. We've actually contributed stuff to this. A lot of these companies up here in open source projects have contributed to Iceberg to make it even better. I think that's the most important thing here, because some of the Iceberg stuff was just written for Spark. So we said, okay, that doesn't work for us. So we issued PRs against it. Now we have like different kinds of features on the Iceberg API, which is what I really like, especially being stuck into a like Oracle for many, many years. So on the right hand side, I just have two different folders here. One's called customer land, and I'm going to go into that. And I just have some GZ files, which are just JSON files here with customer information that's compressed. And then I have my sales information. So I'm landing sales information, sales files into a new directory for every day. So this is just TPCH data, but I converted it to JSON. So for every day, I'm landing data in here. Well, this isn't going to be very performant. JSON's not very performant in the first place. And then having all these different kind of folders in here that I have to go search through for these smaller files is not going to be very performant. So what I'm going to do here is I'm going to take this and I'm going to move this data into another section, like I showed you in that diagram. So this is Starburst Galaxy. If you haven't seen it yet or not, there's a very, very simple interface. We have clusters, catalogs, and querying. So you set up a catalog, connect to your data. You have a cluster, set up a cluster, and then you deploy it, and then you start querying the data. That's another thing I like about it. It's just very, very simple. There's nothing you have to worry about. You could just start querying your data. Again, it's your data. That's the most important thing. So I have a query editor here, and I have a little tab up here called blog. So on the left-hand side, I'm going to come down into my AWS, and I have all my different catalogs and connectors that I can connect to, but I'm just going to connect to S3 here. And I have this little blog schema. And there's not much going on in this blog schema here. I've got this view, and I've got that I actually forgot to drop, and I've got my two tables here. So let me go all the way back to the top here, and I'm going to create a new table. I call it sales line. I'm going to go ahead and just drop that. And so I'm going to start from fresh here. So I just have the customer line, which I'm going to drop right now. Where'd you go? No, customer line way at the top, right here. Okay, so now I'm starting from scratch. I have no tables. Now you notice this DDL here is I'm going to create a table that's pointing to this S3 bucket, which is what you see over here, and see the sales land. So it's going to look in sales land here for any data. And now I'm telling it it's ordered. It's a partition by order date. And then I have a format of JSON, so it knows what to look for. And my type is Hive. And in Galaxy, we have something called a Great Lakes connector that will just with one connector will work with Hive type formats. So JSON, CSV, Parquet, Orc, and then Delta Lake and Iceberg as well. So I'm going to go ahead and create this table. And right now I'm just populating, I'm using Glue as a metastore. So Glue is just storing this information out here, but I don't really know anything about these directories that are out here. And that's one of the, I guess, negatives of using the Hive connector, is because the partition information is stored in the Hive metastore versus like an Iceberg or a Delta Lake. That's all stored at the file system level. So I'm going to run this sync real quick here. And we'll give this a quick second to run. I'm going to come back up to this directory up here. Let me go back up here. And while this is doing, it's going to go out and read those different directories there. And it's going to tell Glue that, hey, I have these different directories that are out there. So sorry, my dog is shaking in the background. So this just takes a quick second. And then what we'll do is we're going to go ahead and create the exact same thing here for the customer information. So the other thing I could do here is what Monica talked about is do some schema exploration here. So if I click on the S3 Lakehouse here and click on Run Discovery, and I just type in, this works on all 3 clouds, and I click on Run Discovery. I think what happened was, was that the wrong table? So 3 sales land. Do I not have it there yet? Oh, I want to do customer land. Sorry, my bad. We'll go and do this. I don't know if it's going to work with while I'm doing my sync. This sync took 30 seconds last time, so I'm not sure if AWS is just taking a little bit to actually work or not. So we'll give this a quick second while I'm going to keep going through the DDL as I go while I'm waiting for that. So the next thing we're going to do is we have this customer table. That's very, very similar. This isn't partitioned. So I just have a format of JSON, the same thing as a Hive. And then I'm going to point to the customer information here. So now just because that's compressed, it doesn't matter if it's compressed or uncompressed. We just see that those files in there no matter what. Then the next thing I'm going to do is I'm going to create a Iceberg table. So this is going to be that next layer that I talked about here. The next layer here is the structured area. So if I come back up to here, I'm going to create a table that's just pointing to my sales base, and it's going to be Iceberg. And I'm still going to partition by order date because a lot of my queries are by order date. So I'm doing like weeks at a time, months at a time for order date. So there's no reason to read every single file that's out there. So this will help with partition pruning, as we call it. It'll only have to go after the files that equal these certain kind of order dates. Whew, man, that took a long time. Okay, let's try this again. So now I can actually select from that table. So all we were doing is just telling Glue that here's these different directories that are out there. That's why Iceberg and Delta Lake are so good, because it doesn't rely upon the Hive metastore so much. It's still just, like for Iceberg, it just keeps a pointer out there. That's about it. So the next thing I'm going to do is I'm running a little bit behind. So I'm going to go ahead and keep going here. I'm going to create that customer land table. And now if I just say select from customer land, there's nothing I have to do with partition. So I only have four customers in here, just kind of playing around with this. Next thing I'm going to do is create that next table that I talked about, that sales base table. Now I don't have any data. I just created the table. Now I need to move that data from that landing area into this base area. So I'm going to do this initial load here, and I'm going to make it super fast here by changing the partitions here. I'm going to go ahead and run this. We're running like a 4-node cluster here, so it's not too bad. This actually goes pretty quick. So it's going to go through all those directories out there and all those JSON files. It's going to insert that into my Iceberg table. So that was pretty quick. And now if I say select star from my base, now I have that built up. And I can also do incremental loads. So instead of just loading the whole entire thing, let's say I'm going to insert a row into my sales land table. Oh, I kind of messed that up. Forgot to fix that. But what I could do is just say, okay, I'm only want to insert new data that's arrived. So let's say I run this every hour. I don't want to just go through all my data. So I'm just going to go back and look for the date. So if I just want to say like yesterday's date, I can do that. There's a bunch of different ways. You could do a merge in here as well. So there's lots of different ways to take that data from one basic layer to the next layer. So next is the customer base. I'm going to go ahead and build out. This is going to be just straight Iceberg. And then I'm going to do an insert from my landing area into my customer. And I'm to say, hey, I want to know what customers don't exist yet in here, and go ahead and insert them. And the next thing I could do is if I wanted to do an update, you could do a merge into the customer base using that customer land. And I'm going to update the name, state, zip code, and customer sent. So these are like the main 4 columns that are descriptions about that customer. So I could run a merge if I wanted to. And this is probably more likely, or you could also do a type 2 where you're doing an insert, a new row, and then you're end dating the old row. So lots of different kind of situations that you could do with merge, which is really nice. The next thing I want to do is I want to do some reporting tables. So this is that last part that I showed you here. So I want to do reporting tables by week, month, and year. Very, very easy. I can do a create table here. So the create table, select the sum, and then where the order date is greater than that. And then I'm just going to go for the last date for the week. So there's that. And then I'm going to do the exact same thing, but I'm going to change this order date where the date format is going to be per month. And then I'm going to do per year. So now this just takes a quick second. I'm going to go back out here and expand my blog over here. And now I have all my tables. Now let's go back to here. If you're curious what it looks like in S3. So we just recently made a change to the Iceberg and the Delta connector to make unique names in here. The reason why we did that is because for renaming. And as you might know, S3 and Google, they do not let you just rename things. You can in ADOS, but like in S3, you just can't rename a folder. You can't rename a file. So what we do here is we have a unique UUID after this, and then that allows the table to be renamed. And then another table, if you wanted to create monthly sales roll-up, to be created out here. If we just had like monthly sales roll-up and you renamed it, there's no way for us to rename that underneath. So that's why you'll see like different kind of names out here. So if we were to go look in the customer base that I showed you before, so Iceberg has basically a metadata layer on top of the data. If I click in the data directory, these are just org files that are out there. Now, if I go back to that metadata directory, these are the metadata. So this is what you're looking at here is Iceberg. Iceberg is just metadata. It's just we call it a table format. Think of like a bank transaction log, a transaction log in a database, same kind of thing. So this is just keeping track of what's going on in the database. I'm sorry, in the table. So if I were to do another insert or an update or something into here, you'll see this grow bigger. So I actually do have an update down in here. I have this update customer, and that's another thing that Iceberg allows us to do is DML. So you'll see that a lot. I just got off a call before this that they couldn't do a lot of this because a lot of the data they were landing in their data lake was just like JSON, and they couldn't do updates. And I can't remember what the California, I actually had to look it up. There's a California one. It's kind of like GDPR, but it's for California. But they couldn't delete the data. So they were kind of getting in big trouble because they couldn't do this. So now you could do this. They could do deletes. They could do updates, any of this stuff. So if I were to do an update here, notice that there's 1, 2, 3, 4, 5 files over here. Let's see if this runs. And I do have my customer base, customer Iceberg. Hopefully this is the right one. Oh, I did that customer base. That's why. Let's try this again. That's why I love doing demos in real life. So,
I know.
awesome. All right. Anyway, so if I was going to do a customer base, now I have to do it because I'm really, really stubborn. Because I just there we go. Right. Oh, there's my update right here. So if I get the right table name. Oh, there we go. Let's see if that customer exists. Yes, it does. Oh, it didn't really do anything. No rows. Okay. Well, if that actually worked, you'd have more files here. So basically, you're looking at a transaction layer for a customer. So now you can see all the different kind of Iceberg tables that are sitting out here. That's what you'll notice. You'll have my sales land and my customer base. And then we could do deletes if we wanted to. Optimize. The reason why optimize is here is because a lot of times you're landing data in a streaming environment. So you're getting really small files. So you want to optimize those tables and make those small files larger, which is very, very important, especially in a streaming environment. And most days, this day, we're micro batching data and we want that data to be available as soon as possible. So let me go back up to Iceberg here. So kind of like the features and benefits of it, what we like about it. And same thing with, you can apply a lot of this to Delta Lake as well, is it being able to do snapshots, so be able to go time travel. So that's one thing I did not show. I actually have under my reporting here, where'd it go over here? I have time travel in here somewhere. I had it right underneath there. All right. Anyway, it's not in here. I thought I had it right before here, but I guess not. Okay. So what time travel does, it just allows you, since we're doing snapshots. So if you look in here, we had a snapshot file in here. So snapshot files are just basically point in time of a table at a certain time. So every single modification you do to a table, it's going to create a new snapshot. So we're able to actually go back in time and say, okay, give me the snapshot that you were using for a certain time. So which is really, really nice, especially if you're doing a lot of stuff. So I actually have it right here. So in every single table we have metadata. So there's all this metadata that we keep about Iceberg, and we can actually go query it from those files. You can see the manifest, the partitions, all sorts of really cool information. So in here, this customer Iceberg table that I have these different snapshots available. So what happened was I was doing some updates. So I can actually come back in here and say, I want to go back in time and I want to query this table before my update statement. And so it's going to give me this information back. And now if I put this in before. I can't remember if I did an actual update on this table or not. But if it was before and after, you'll get before and after information. I can also do timestamps as well. So if I want to know the customer name from last week, Wednesday or something like that, I don't need to know that timestamp. I mean, I'm sorry, I don't need to know snapshot ID. I can just do by timestamp as well. So that's another big kind of big benefit of something like Iceberg that brings to the Lakehouse, which you couldn't do before. Same thing with rolling back. If I did screw something up, I had a load that went in and it was partial or something bad happened, I can actually go into this table and figure out what snapshot I want, and I can actually roll back to that snapshot. There's also other things too that are more database type functionality in the Lakehouse, is like renaming and adding columns. That was very difficult to do in the Hive world. You can obviously, I talked about before, is rename a table, but also renaming columns. The other part too is changing the partition. So if I want to know, typically if I partition, I'm going to partition, let's say, by month. And then I realize that, month is not big enough. I'm actually having a lot of people do queries by day or by multiple days. And so you can actually do an alter table on that and change the partitioning to day. So that's a big difference. Like that's what you'll see, like when we talk about Lakehouse running or Starburst, is because before it was the data lake, and now we're bringing more and more functionality. Everything that I just showed you right here, we could do this in databases for many, many years, but you couldn't do this on a data lake, with petabyte data. And this is the big difference, like something like Iceberg. That's why we've put so much work into it this year that really rounds out the Lakehouse, being able to do all these little database type functionalities in here. So I think that's all I wanted to cover, Monica.
Yeah, that was awesome. I loved it. Coming from a Hive background or a traditional like on-prem background, the power that you have with Iceberg and Delta Lake and being able to really apply those table formats to your data lake, it really just blows out the lake house of what you can do.
Yeah, it really lets you actually be serious about this, especially after
Yeah.
last call. He was like, "Oh, we're really down on data lakes," and we talked about Iceberg and what we can do and stuff like that. And he's like, "I didn't even know we could do this stuff now." And I'm like,
Right.
"Yeah, you don't need to go into this very, very expensive, cloud data warehouse to have this functionality now. You can still have this whole separation of compute and storage and have all the cool database type functionality that you missed." So
Yeah, absolutely. If you let me share my screen again, I can talk a little bit more about, what's coming soon, and we can, if you can give me a response, you can see. Is that my screen?
oh yeah, sorry, go ahead.
No,
Yeah.
you're good. Like Tom mentioned, we're working very hard on trying to get that functionality for these table formats even better and better, and really working on those table maintenance. Right here we have sort of an image of what I previously showed you for the lake house. This is what we're working on to just make the lake house even better. And as we talked about already, the table maintenance components of optimize and trying to make all of those commands just more even functionality to your data lake house than you had with your data than you had before. We also are working on data discovery to try and help you get the most out of your data. So it's enhancing that schema discovery feature that we talked about, and really letting you kind of preview your data, dive in and work on it even before. We also have some connector coming. We have many connectors in the works, but we're ready to talk that we have the Elasticsearch connector on its way. And we also are working on getting our tabular Metastore connection. And this is a big one for open table formats expanding. We're trying to expand to the Hootie connector. And we're also working on, we have our fault tolerant execution going to all clouds. And we have cluster scheduling coming, which will help you kind of customize your clusters even more. We have client SSO on your side coming, and then also Tableau Online. So I just want to, again, touch base that Starburst Galaxy is the easiest way to get started with Trino. And we also offer the 24/7 support, really with the Trino experts. We have the co-creators of Trino, and we are here to really offer the best platform with the most security and the most connectivity. So I think we're going to jump to questions now. Oh, well, sign up for Starburst Galaxy. So cool. There's a bunch of different demos that you can do, or we have a data lake analytics one. You can, when Tom's blog drops, you can try it for yourself. So there's a lot of different functionality to work through.
The rate I'm going will be next year, but no, it'll be in the next week, I promise.
And then you can try out merge. It'll be awesome. So do we have any questions that we want to discuss?
Yeah, if you have any questions, especially like about Iceberg or Galaxy or Trino or any kind of roadmap items or anything like that.
Yeah, I think there's one about what would you say to someone who is thinking about switching to a data lakehouse but is worried about the time investment?
I think it's very well baked now, I think is the good term for it. I think a majority of people, what I saw back in my day was we had a warehouse and we would take all the source systems and we would put everything into a raw or stage area in a data warehouse. And then from there you go on your layers. And then Hadoop came out and people kind of didn't know what to do with it. So that became like the place where you staged everything first. And then you would move that data up to like a data warehouse, and then you would have all your raw data and then a bunch of other data that didn't make sense to go in the data warehouse. Now that whole pattern's moved to the cloud, and people are doing usually the same thing. They're not usually going directly into a cloud data warehouse or something like that. They're usually landing on S3 or cloud storage first, and then going up to those aggregation or rolling up or whatever it is, or going up to a cloud data warehouse. When they may not realize that what I just showed right there, you can create everything right on top of S3. So that allows you the openness to like, okay, great. Starburst and Trino are here right now, but maybe in a year or two, there's something else comes along, maybe some more machine learning, AI type. So it kind of opens you up, but it's just your data there. And then you get to go shop for whatever processing engine out there that makes sense for you at the time.
Right.
Otherwise, you're just, now you have data in two places, just like we said we didn't want to go do. And now you're like, okay, what happens to this cloud data warehouse is becoming too expensive. That's what we keep seeing here in the last pretty much 6 to 10 months is it's just way too expensive. And then we say, okay, no, some of these reporting structures up, just leave them on S3. And they're like, wow, we didn't know you could do that. So I think the functionality already exists, it's there. And then it's even getting better. Every month goes by, there's more, not only just from us, but you saw that list of vendors out there. I mean, it's pretty exciting time right now. So
yeah, absolutely. There's a couple questions in the chat. The first one being, does Starburst Galaxy offer a load balancing feature?
Not right now. We haven't seen, most of the time, most of our customers use different clusters for different workloads. And that's the extra dimension that we've added in Galaxy, where it's point and click. You have different clusters for different workloads. On-prem, or even when you're doing the self-hosted, it was a lot more difficult to do that. So we have a lot of customers just one cluster and everybody's fighting for it. And you don't have to do that anymore. So there's less of a need to do load balancing versus just trying to separate that workload out, either between workloads or different workload types, or different departments. So I think eventually we may add something like that. We've been asked by a couple customers that, but I think they've solved that by just breaking that out to other clusters. But I'm sure that'll come soon.
Yeah. And then like you said, there's different ways to really kind of combat that with the cluster separation. And another question, the pattern design that we talked about today, our reporting structure, is that we did it on AWS today, but is that available or viable in Azure or OCI? What do you think about that?
Yep. So Iceberg, Merge, all that stuff works on and Delta Lake to all three clouds seamlessly. So we want to make sure that we offer that as well. So that's been tested. I was testing a bunch of Merge stuff out on all three clouds and it worked great.
That's Tom's side job, is QA.
Yeah, I am a great person. I love it. That's okay. And then Snowflake, yeah, we do. I didn't show that in Galaxy, but we do have a Snowflake connector in Galaxy, and then in our Starburst Enterprise as well. And Starburst Enterprise has two different kind of connectors. One's more of a for large, when people are doing these really, really large joins or pulling out of Snowflake, it basically dumps the query results to S3, and then we read from S3 in parallel. That's one connector. Then we have just a regular JDBC connector, and that's usually what people use for like joining against like a dimension table in Snowflake versus a fact table in S3 or something like that. So
awesome. I think that's all that we have. I want to thank all of y'all for joining. Thank you so much for being here with us, and go sign up for Starburst Galaxy and give it a try yourself.
all right, thanks, Molly.
Thanks.
Thanks, Mia.